All right, hello everybody. Today we're going to learn about significant figures. This is an extremely important topic in chemistry. We're going to have to write all of our answers to all of our math problems all year in the proper number of sig figs. So the first thing we should ask is, what exactly are they? Well, they're not fig Newtons, even though that's figs, and they're not Isaac Newton either. Hey, here's some figs. Down at the bottom we can see the digits on the odometer are significant figures. Another name for significant figures is significant digits. So the 9, the 1, the 3, the 0, and the 8 are all sig figs. What's the deal with the 0 in front? Well, that's a limitation of the car's odometer technology. We know in math class we never write that number down, so we're not going to write it down in chemistry either. That's a leading 0. It's not significant and never will be. So what exactly are significant figures? They're the certain digits in the first uncertain digit read from a measuring device. We know that the first uncertain digit is the estimated digit. Just because it's estimated doesn't mean it's not significant. For instance, in the car odometer down here, the 8 is the estimated digit because there's decimal points after that. We don't know what those decimal points are, but those decimal points were used to round the 8. So again, the 9, the 1, the 3, the 0, and the 8 are all sig figs, so there's a total of 5 sig figs in this problem. All right. So what do we do in the laboratory? Well, the easy answer is you put something on the measuring device and you just read the measuring device. So I'm going to put a mole on this measuring device, and we see a bunch of digits down here for the mass of the mole. So the mole weighs 623.10 grams. All of these are significant figures. So again, we just read off the digits from the measuring device, including the 0. The 0 is significant. The 0 is the estimated digit. You got to write the 0 down on paper. So that 0 is a significant figure, and if you don't write the 0 down, it would give the impression that this was only 4 sig figs, when in fact it's 5 sig figs because of the 5 digits there. All right, so we always have to report our measurements using the correct number of sig figs. Let me give you an example, another example of that. This one isn't a digital scale, it's a speedometer from a car, and we can see that the measurement is between 120 and 130. You might think at first that the car is going really fast, but that's kilometers per hour. Oh wait, it actually is going fast because it's around 80 miles per hour, but that's under the speed limit in Montana, I think. So anyway, here's the measurement. It's between 120 and 130. I'm going to call that measurement 128. You could call that 127 or 129. Both of those are also okay because they're within uncertainty. They're technically the correct answer. So 128 is the correct answer. But here's not the correct answer. 128.3864. If you wrote that down as the speed, you'd be totally off your chair, bonkers. You can't write down all those decimal points because they have no basis in reality. The measuring device here didn't read them. If a police officer wrote that down on a ticket for the fact that you were speeding, it would get thrown out of court and you wouldn't have to pay the ticket because there's no measuring device that would actually be able to read those decimal places. So instead, you got to write down 128 kilometers per hour. How many sig figs? 3. You can't write more than 3. This measuring device isn't capable of measuring more than 3 sig figs. All right, there are also sig figs of counting numbers. These are not measurements. I did not use a clock to measure the fact that 60 minutes are in an hour. That is a definition. It's exactly 60 minutes. It's not around 60 minutes. It's exact. It's not like some hour somewhere could be 60.1 minutes. So this has infinite sig figs. All right. Also, people always have to come in whole numbers. If this guy loses his arm, ouch, but that doesn't make him less of a person because of it. There's no such thing as 0.1 of a person or 0.9 of a person. So this is 2 people, and it's exactly 2 people. So infinite zeros after it, so that's infinite sig figs as well. So again, counting numbers and definitions, we just say that they have infinite sig figs because they're not actually measurements. Let's talk about when we count sig figs, though, when people write down numbers. So this is not when you're doing the measurement yourself. This is when somebody else did the measurement, like your lab partner or a textbook or some scientist. We're going to use something called the Atlantic-Pacific rule. Atlantic and Pacific is just short for decimal being absent and present. And Pacific is just a convenient way to remember left, and Atlantic's a convenient way to remember right. And the number is in the middle, and I don't know why Nova Scotia is part of the United States, but whatever. All right, so I'm going to reword this a little bit because the wording could be a little confusing. Instead of writing the rightmost non-zero digit, I'm just going to write number. and leftmost non-zero digit, I'm going to write number. So all this says is the only thing that we ever have to worry about, is it significant or not, are zeros. And this rule will let us decide whether a zero is significant or not. If the decimal is absent, zeros on the Atlantic side of the number are not significant. If the decimal is present, zeros on the Pacific side of the number is not significant. All other digits are significant, including other zeros. Sometimes zeros are, sometimes zeros aren't. But this is the rule we're going to use. So let's apply it to a few examples. First example is this. Is the decimal absent or present? I say it's absent. And the reason it's absent is because there's no decimal there. Well, there's an assumed decimal there, but there's not one actually written down. So let's start on the Atlantic side. Atlantic's over here, and I'm going to go until I hit a non-zero digit, which is the 7. So all of those zeros are not significant. But all other digits are. So the 5 and the 7 are significant. That makes it 2 sig figs in this problem. Let's do another one. I'm going to do 0.0050 centimeters. This is a case where the decimal is present. So we start on the Pacific side. All right, it's a big misconception to stop at the decimal. Don't stop at the decimal. Stop at the first non-zero digit. So I'm going to keep going until I hit the first non-zero digit, which is the 5. That means all of these zeros are not significant. Again, don't stop at the decimal. F-I-C-A-N-T. There we go, significant. All right, so since those zeros aren't, the rule also says everything else is significant. So that means the 5 is significant and this 0 is significant because it's not on the Pacific side. So this number has 2 sig figs. All right, let's move on to one more. You guys do this one on your own. So you should be asking yourself, is the decimal absent or present? Do I start on the Atlantic or Pacific side? Which zeros are significant, which zeros aren't? And how many sig figs are there? All right, so let's do this together. Decimal is absent, start on the Atlantic, go till you hit the 6. That 0 is not significant. All the other digits are. That makes it 3 sig figs in this problem. All right, I'm going to trick you on the next one. It's a trick. You might think there's 2 sig figs here, which it would be if it was any unit other than people. But people is a counting number. You can't use a measuring device to count people. So therefore, this actually has infinite sig figs because